All right, learning target 2, we are talking about calculating the rate of change from a table. But first we need to get a couple kind of definitions down. These are both things you've heard about before, or at least heard of before. The first is an independent variable. And an independent variable is a variable whose values impact another variable. On a graph, this variable lies on the horizontal axis, which we know is the x-axis. So along this x-axis is where we put the independent variable. A good example of this is time. Time is, unless you're talking about it in a very specific sense, time is almost always an independent variable. And the reason for that is it's not impacted really by anything else. Like time is still going to go on. The seconds are still going to tick by if we're talking about a race. If we're talking about a road trip or something. Time is still going to keep moving forward, and it's not impacted at all by any other variable around it. Okay, it's going to keep going, and no other variable around it can have any sort of effect on time. So that's a pretty typical independent variable. A dependent variable is a variable whose values depend on another variable. So this word depend shows up right there in dependent variable, a variable whose values depend on another variable. On a graph, this is the variable that lies on the vertical or y-axis. So this is our dependent variable up here on the y-axis. Okay, and so a dependent variable can be something like distance. In our last video, it was distance from the classroom. Or in the example in class from block day, it was the distance to the finish line in my race with Mr. Dunn. So the dependent variable depends on the other one. So in that case, our distance from somewhere depended on time. So as time went on, we got closer and closer to the finish line, or closer and closer to class. In a scientific sense, the dependent variable can be the thing that you're trying to measure. So if you're doing a study on plant growth, and you want you're studying how tall it gets, the dependent variable would be the height of the plant, and an independent variable could be how much you water it, or how much sunlight you give it. Okay, how much you water it is not at all dependent on the height of the plant, unless you later change your mind and you're like, oh, this thing's not growing at all, like maybe I should water it more. But the sunlight, like how much sunlight you give it, that is totally up to you. That's the variable that you control, and this is the one that you are studying. Okay, so back to our example of the race with me and Mr. Dunn, the independent variable was time. Okay, time went on no matter what. It was not impacted by how the race was going. But how the race was going, how far we were from the finish line, was definitely impacted by time. Okay, so there is a relationship between the two. An example for you here of a linear relationship. The table below relates the wind chill versus the actual temperature outside. And so a lot of times the wind chill is what it actually feels like outside. And typically it's colder. Like if you think in the winter, if it's a low temperature outside, usually the wind chill is lower because the wind is kind of making it feel colder. And it was calculated when the wind speed was 15 miles an hour. So assume that the wind chill is a linear relationship, and these temperatures that we've measured span from -5 degrees to 35 degrees. So our independent variable here is the temperature. because temperature is not affected by wind chill. Wind chill is affected by temperature. So wind chill is the dependent variable because that's the one that depends on the temperature. The lower the temperature, the lower the wind chill. The higher the temperature, the higher the wind chill. Okay, but not necessarily the other way around. All right. When it comes to calculating the rate of change, we talked about rate of change as a lot of different things. We talked about it as slope. We talked about it as rise over run. We talked about it as change in y over change in x. And that's the one that I want to use when I calculate this. Okay, so I've already kind of figured out that my y variable is the wind chill and my x variable is the temperature, because typically x is the independent and y is the dependent. So for my change in y over change in x, I'm going to look for change in y, and I'm going to go from point to point here on the table. And if you find the difference between these two, you'll find that in this table it's going up by 6.4 degrees each time. And so we can fill in the rest of this table by going up another 6.4 degrees. That would be negative 6.6 degrees. And if I go up another 6.4, that would be negative 0.2 degrees. And if we check there, negative 0.2 plus 6.4 is 6.2 degrees. We can go up to that point, get 12.6 degrees, and then check there again. It's going up by 6.4 degrees every time. Okay, so our change in y is 6.4. Now we need to find the change in x, and this one's relatively simple. This is just going up by 5 degrees, up by 5 degrees, up by 5 degrees, all the way across this table. So our change in the x variable, or the independent variable, is 5. And really I should probably put a positive there. So we're going up by 6.4 degrees and up by 5 degrees. So our rate of change then is just the change in y, which is 6.4, divided by the change in x, which is 5. And so that equals 1.28. So our rate of change is 1.28. Okay. Now, that's fantastic if you can calculate that, but if we don't really know what it means, it's not really that interesting. So interpreting the rate of change is really just asking, okay, what does this 1.8 number mean as it relates to our situation up here? So that 1.8 means that every time you increase by 1 degree in the temperature, increasing the temperature by 1 degree increases the wind chill by 1 degree. By 1.28 degrees. So every time our temperature increases by 1 degree, the wind chill increases by 1.28 degrees. You could go the same way backwards and say each time that the temperature decreases by 1 degree, the wind chill decreases by 1.28 degrees. Okay, so it could kind of go both ways with that. Our starting value, we talked in the previous video about how the starting value is just whenever x equals 0. And so conveniently for us, x equals 0 is on that table. So when x equals 0, y equals negative 19.4. So when the temp is 0 degrees, the wind chill is negative 19.4 degrees. Okay, and that's our starting value. So we can take our slope and our starting value and write a linear equation from it. And this is going to be a y equals mx plus b type equation. M is the slope, or rate of change, which in this case was 1.28. And b was the starting value, which was negative 19.4. Okay, so our slope was 1.28. Our starting value was negative 19.4, so you just plug them into the y equals mx plus b equation. And that is the equation that models this relationship. All right. Your before class gives you a little table here of a company selling a new energy drink. It shows their number of bottles sold versus their profit. So probably the first thing you actually want to do for this is identify the independent variable and the dependent variable. From that point, you can calculate and interpret the rate of change. What is the rate of change? What does it mean? And what is the starting value? And then what does that mean as well? So sort of answer these same questions and go through the same process from this example for your before class.